What is plasma? What is the role of plasma in nuclear fusion?
So plasma is a phase of matter or state of matter. So unfortunately, our schools don't. It's like I'm not sure why this is the case, but all children learn the three phases of matter, right? So, and what does this mean? So we'll take like water as an example. So if it's cold, it's ice. It's in a solid phase, right? And then if you heat it up, it's the temperature that typically sets the phase. Although it's not only temperature. So you heat it up and you go to a liquid, and obviously it changes its physical properties because you can pour it and so forth, right? And then if you heat this up enough, it turns into a gas, and a gas behaves differently because there's a very sudden change in the density. Actually, that's what's happening. So it changes by about a factor of 10,000 in density from the liquid phase into when you make it into steam at atmospheric pressure. All very good. Except the problem is they forgot like what happens if you just keep elevating the temperature.
You don't want to give kids ideas. They're going to start experimenting, and they're going to start heating up the gas.
It's good to start doing anyway. So it turns out that once you get above, it's approximately 5 or 10,000 degrees Celsius, then you hit a new phase of matter. And actually, that's the phase of matter that is for pretty much all the temperatures that are above that as well too. And so what does that mean? So it actually changes phase. So it's a different state of matter. And the reason that it becomes a different state of matter is that it's hot enough that what happens is that the atoms that make up, remember, go back to Feynman, right? Everything's made up of these individual things, these atoms. But atoms can actually themselves be, which are made of nuclei, which contain the positive particles and the neutrons, and then the electrons, which are very, very light, very much less mass than the nucleus, and that surround us. This is what makes up an atom. So a plasma is what happens when you start pulling away enough of those electrons that they're free from the ions. So almost all the atoms that make up us up and this water and all that, the electrons are in tightly bound states, and basically they're extremely stable. Once you're at about 5,000 or 10,000 degrees, you start pulling off the electrons. And what this means is that now the medium that is there, its constituent particles mostly have net charge on them. So why does that matter? It's because now this means that the particles can interact through their electric charge. In some sense, they were when it was in the atom as well too. But now that they're free particles, this means that it fundamentally changes the behavior. It doesn't behave like a gas. It doesn't behave like a solid or a liquid. It behaves like a plasma, right? And so why is it disappointing that we don't speak about this? It's because 99% of the universe is in the plasma state. It's called stars. And in fact, our own sun, at the center of the sun is clearly a plasma. But actually the surface of the sun, which is around 5,500 Celsius, is also a plasma. Because it's hot enough that is that. In fact, the things that you see, sometimes you see these pictures from the surface of the sun, amazing, like satellite photographs of like those big arms of things and of light coming off of the surface of the sun and solar flares. Those are plasmas.
What are some interesting ways that this fourth state of matter is different than gas?
Let's go to how a gas works, right? So the reason a gas, and it goes back to Feynman's brilliance in saying that this is the most important concept. The reason actually solid, liquid, and gas phases work is because the nature of the interaction between the atoms changes. And so in a gas, you can think of this as being this room, and the things, although you can't see them, is that the molecules are flying around, but then with some frequency, they basically bounce into each other. Mm-hmm. And when they bounce into each other, they exchange momentum and energy around on this. And so it turns out that the probability and the distances and the scattering of what they do, it's those interactions that set the about how a gas behaves. Mm-hmm. So what do you mean by this? Well, so for example, if I take an imaginary test particle of some kind, like I spray something into the air that's got a particular color. In fact, you can do it in liquids as well too. Like how it gradually will disperse away from you. This is fundamentally set because of the way that those particles are bouncing into each
The
other.
probabilities of those the
Yeah.
particle bouncing.
The rate that they go at and the distance that they go at and so forth. So this was figured out by Einstein and others at the beginning of the Brownian motion, all these kinds of things. These were set up at the beginning of the last century, and it was really like this great revelation. Wow, this is why matter behaves the way that it does. Like, wow. But it's really like, and also in liquids and in solids, like what really matters is how you're interacting with your nearest neighbor.
Mm-hmm.
So you think about that one, the gas particles are basically going around until they actually hit into each other, though, they don't really exchange information. And it's the same in a liquid, you're kind of beside each other, but you can kind of move around. And in a solid, you're literally like stuck beside your neighbor. You can't move. Like,
yeah.
Plasmas are weird in the sense is that it's not like that. So, and it's because the particles have electric charge. This means that they can push against each other without actually being in close proximity to each other. That's not an infinitely true statement, which it's a little bit more technical, but basically this means that you can start having action or exchange of information at a distance. And that's, in fact, the definition of a plasma, that it says these have a technical name. It's called a Coulomb collision. It just means that it's dictated by this force which is being pushed between the charged particles. Is that the definition of a plasma is a medium in which the collective behavior is dominated by these collisions at a distance. So you can imagine then this starts to give you some strange behaviors. Which I could quickly talk about. Like, for example, one of the most counterintuitive ones is as plasmas get more hot, as they get higher in temperature, then the collisions happen less frequently. It's like what? That doesn't make any sense. When particles go faster, you think they would collide more often. But because the particles are interacting through their electric field, when they're going faster, they actually spend less time in the influential field of each other, and so they talk to each other less in an energy and momentum exchange point of view. Just one of the counterintuitive aspects of plasmas,
which is probably very relevant for nuclear fusion.
Yes, exactly.